So for those two, I would look at my a's and I would say I have a cubed over a. So I would subtract 3 minus 1. That's how I would get my a squared. B over b cubed. I would subtract, I would get 2 there, but it's 2 negative. 1 minus 3 is negative. So that actually tells me the b goes to the bottom. You can also see where your higher exponent is. That's where it's going to end up. And then for the c, I have 4 over 1. Subtract and you get c to the third. And so we reduce that. For this one, I reduce my numbers first. 112 over 2, that gives me the 56. My x's, 8 minus 4. My y's, I had a 3 on bottom, so that's going to be where it is. 3 minus 2, a 1 on bottom. So for this one, you should have just multiplied through. Remember, when you're multiplying like bases, you add their exponents. Find the zeros. When it's given to you like this, the zeros are asking for the x-intercept. So where this whole function equals 0 is what it's asking. So you should have factored this, factors of 42 that add up to 13, set each factor equal to 0. And so you would have gotten x plus 7, x plus 6 as your factors, then set each factor equal to 0. Negative 7 and negative 6 would have been your zeros. When it's already factored for you like this, all you have to do is set each one of these equal to 0, and you will get your zeros of your function. So if it's already factored, it's nice and easy. Subtract 2, you get a negative 2. Add 8, add 6. So these are your 3 zeros for that one. So first of all, we'll talk about what a polynomial is. A polynomial is what we have been dealing with. A quadratic is a type of polynomial. It's a polynomial with a degree of 2, meaning your highest exponent is 2. Polynomials are really just any monomial, so any number and variable multiplied together, and then you take those and add them up, right? So a monomial is just one term, a binomial 2 terms, a trinomial 3 terms, and then you go polynomial from there with multiple terms. So they just wanted to remind you, first of all, the first thing we're going to do with dividing is what happens when we're dividing by a monomial. There's no plus or minus down there in the denominator. When you have a single element down here, like this, you can take each piece of the numerator and divide it by that denominator. All right, so if I have, and you can really do that all the time, but it helps you most when there's a monomial. So if I have a plus b plus c over d, I can put each piece, a over d plus b over d plus c over d. Well, that helps us sometimes when it looks like this, because if I want to divide this whole thing by this 3xyz, I can put each piece over it, and then each of those pieces look like what we did for bell work. We're just going to reduce it. So if I take each of those pieces, I would say 3x squared y cubed, and I would put it over 3xyz. And then I would add to that 9x to the 5th yz squared over 3xy and z. And then I would put minus x to the 4th yz to the 5th over 3xyz. Each piece is being divided by it. And so this makes it easier because now I can reduce those just like I did from bell work. So I'm going to go 3 over 3. That's going to cancel out. X squared over x to the first power, I'll have an x on top. Y cubed over y to the first power, I will have a y squared on top. My z cannot reduce with anything, so it remains on the denominator. Then I'm going to go to my next piece. What is 9 divided by 3? 3, and so I have a 3 in the numerator. I have a 5 over x to the 5th over x to the first. On top, 5 minus 1 is 4. I have a y over y. Well, that is just going to cancel out. Anything divided by itself is just 1. And then I have a z to the second power over z to the first power. You'll notice I reduced this guy. I reduced this out, that canceled out, and I reduced that out, that's on top. So I actually don't have a denominator for this second term. All of my denominators went to 1. Then I'm going to subtract. In this case, my 3 in the denominator cannot reduce, so I will have a 3 down there. And then I'm going to look at my variables, x to the 4th over x to the 1st. That's going to give me x cubed. My y's, once again, I have a y to the 1st, y to the 1st. Those are going to cancel out because they turn to a 1. And then I have z to the 5th over z to the 1st. I will have z to the 4th. And this is actually my answer. That's what happens when I divide that out. With a monomial on bottom, the easiest way to do this is to take each piece and divide it. And when you're dividing, you're just reducing. Think of it as a fraction that you're reducing out. So there are also going to be times when you are dividing polynomials by polynomials, meaning I have a plus or minus in what I am dividing by. It can look like this. They could say divide x cubed plus 4x squared plus x minus 6 by x squared plus x minus 2, or they could write it in fraction form. Either way, it means the same thing. You just need to recognize what they're asking. So they could also write it this way. All right. The other method that we're going to do, besides just simply putting it over and dividing, is doing what is called long division. We should all remember that term. So, long division. When you have something like this, divide this guy by that guy, or when it's written like this, what goes on the inside? Well, the guy that's being divided. So this would be going on the inside. If it's in fraction form, your numerator. And you are going to set this up just like you would long division. You would say x cubed plus 4x squared plus x minus 6. I want to point something out. In this case, they have all the pieces that they need. But if you start with x cubed, you must have a placeholder for all of your degrees going down. So if I have an x cubed, I must have an x squared and an x to the first power and a constant without an x. If you are missing any of these, put a 0 there as a placeholder so that you don't mess up what you're doing, okay? So if you're missing anything, if you start with a 3, you have to have a 3, 2, 1, and 1 without a 3, 1 without an x at all, okay? And if you're missing any of those, just put a 0. That goes on the inside. On the outside is what you're dividing by. So we're going to say x squared plus x minus 2. That's on the outside. Now, when I decide how I'm going to do this process, remember in long division, you looked at what's on the outside, how many times do you multiply that guy to get the inside, right? And then you go from there. That's exactly what we're doing, but we're just going to look at the first terms. So we're going to say, what do I need to multiply x squared by to get x cubed? All right? So what do I have to multiply x squared by to get x cubed? Just an x. So I'm going to say, well, I multiply by an x. Here's what I do with that. I multiply every single piece by that x. So I say x times x squared gives me x cubed. X times x gives me a positive x squared. X times negative 2 gives me a negative 2x. All right? Now, what do I do when I'm doing long division? What do I do going down? Add or subtract? I subtract. Now, because I'm subtracting a group, the way that I do this is I say I'm adding the opposite, okay? The reason I do this is you forget and you subtract the first one, and then you end up not subtracting the rest of them, okay? And so I always say that I am adding the opposite. So I change that to a negative, I change this to a negative, and I change this to a positive, okay? Because what happens here is you're technically subtracting a negative, and people forget to do that, okay? So I always change it to adding the opposite just so that I don't mess up my positives and negatives. And so I have a positive x cubed and a negative x cubed. Those will cancel. And then I have a 4x squared and a negative 1x squared. That gives me a 3x squared. I have a 1x and a 2x. That gives me a 3x. And then just like in long division, I bring down that guy right there. So I'm going to bring down a negative 6. All right. Next, x squared. So I'm going to now compare x squared to 3x squared. What do I need to multiply by for x squared to get 3x squared? 3. So I'm going to say a positive 3, and I'm going to multiply that through. I'm going to say 3 times x squared, 3 times x, and 3 times negative 2. And then I am adding the opposite here. So these are all opposite. And you'll see in this case, they zero out. So we're going to say 3x and negative 3x squared. These cancel, these cancel. I have a remainder of 0. Remainder of 0. So my answer here is going to be x plus 3. When I divide this by that, I get x plus 3. We had a 0 as a remainder. When you have a 0 as a remainder, then that is a factor of your function, all right? Think of it with long division. If I take 21 and I divide by 3, will I have a remainder? I will not, right? Because it's 7 with no remainder. Why? Well, 3 is a factor of 21. If I were to do a factor tree and factor 21, I would get 3 and 7. It's a factor, right? But let's say I were to take 22 and divide by 3. I would have a remainder, right? A remainder of anything tells you, other than 0, tells you that it's not a factor. 3 is not a factor of 22. And the reason you know that with long division is that you have a remainder other than 0. And the same thing is true of polynomials. If we were to take a trinomial and factor it, right, we would get our 2 factors. If we were to divide that polynomial by one of its factors, your remainder is going to be 0, always. So when we divided that last one, not only were we able to come up with the answer, we could also tell you that what we divided by was a factor of our original polynomial. And so having a remainder of 0 tells you you have a factor. If you get anything other than 0, it's fine. You divided, just like if you divided 22 by 3, you can divide it. But it also tells you you do not have a factor. So your remainder actually tells you some information about that particular polynomial and its relationship to what you're dividing by. So this is saying determine whether x minus 2 is a factor. Well, the one way we can tell if it's a factor is we can just divide. Divide and see if we get a remainder of 0. And so that's what we're going to do. We're going to take this. This is going to go on the inside. I have 3x cubed minus 8x squared. What am I missing? Remember I said I had to have 1 for each. I am missing something with a just an x. So I'm going to say plus 0x plus 14. I'm dividing by x minus 2. All right. What do I need to multiply x by to get 3x cubed? A 3 and an x squared, right? So I'm going to say 3x squared, and I'm going to multiply through. 3x squared times x is 3x cubed. 3x squared times negative 2 is negative 6x squared. I'm going to do adding the opposite here. 3 and negative 3 cancel. Negative 8 and positive 6 give me a negative 2x squared. And I'm going to bring down the 0x. I'm going to do the same thing here. What do I multiply x by to get negative 2x squared? Well, a negative 2 and an x. Negative 2x times x is negative 2x squared. Negative 2x times negative 2 is positive 4x. And remember, I am adding the opposite here. So I'm going to say adding the opposite of each of these. Negative 2 and positive 2 cancel. 0 and negative 4 give me a negative 4x. And I am going to bring down this 14. What do I multiply x by to get negative 4x? Well, that's a negative 4. And then I'm going to multiply through negative 4 times x. Negative 4 times negative 2. And again, I am adding the opposite here. 14 and negative 8 give me a remainder of 6. So what does that tell me about what I divided by? This is not a factor of that. It is not a factor. But I still do the division. Now in your book, they will also often just put like R6, like you did old school when you were doing it, when you first started learning to divide, right? Oh, yeah. But there's another way to write the remainder. My answers will always look like this. So when you do this for me, I want the answer when you divide it to look like this. Negative 3x squared minus 2x minus 4. It is a positive 6. What do I do with my remainder usually? I put it over what? Whatever I divided by, right? What's on the outside? So I'm going to say 6 over x minus 2. This is what I want your answers to look like right here, okay? Instead of a remainder of 6, I want you to actually say 6 over what you divided by. Called synthetic division. Basically what synthetic division does is it takes your coefficients of all of your things that's being divided, and it just takes those out. So you kind of do it without the variables, all right? And then you take whatever you are dividing by, set it equal to 0, and that's what's going to go on the outside. Okay, so let me set it up for you first. and then we will go down the process, okay? So you set it like this. It looks almost like an upside down division line is what we're going to do here. And then we're going to take our coefficients. Once again, you need a coefficient for every placeholder. So I started with an x cubed. My coefficient there is 3. X squared, my coefficient there is -8. I do not have an x, so I'm going to put a 0. And then my constant there is 14. That's how you set up the inside, okay? For what goes on the outside, I'm going to take this x minus 2 and I'm going to set it equal to 0. What makes that 0? X equals positive 2, okay? So that's what's going to go out here, a positive 2. That's how you set up synthetic division, all right? For synthetic division, you add down and multiply up, okay? Add down, multiply up. Those are the rules for synthetic division. So you add down, multiply, kind of across is how it's going to look when we do this, all right? So let's do this. 3 plus nothing gives me what? Well, that gives me 3. Now I'm going to multiply 2 times 3. That is going to give me a 6, and that is going to go right here. All right? And then I'm going to add down -8 and positive 6 is going to give me a -2. Then I'm going to say 2 times -2 gives me a -4. 0 plus -4 gives me a -4. And then 2 times -4 gives me a -8. All right? Then I'm going to add down 14 plus -8 gives me a 6. Gives me a 6, all right? Now, what I'm going to do here to find my answer is I'm going to look and see what exponent I started with. I started with an exponent of 3. I'm going to take all of those. Those are now my coefficients, and I'm going to fill in starting 1 down from where I began. So I started with x cubed. I'm now going to fill this in with a squared. So 3x squared minus 2x minus 4, this will always be my remainder. So I'm going to say plus 6 over what I was dividing by, x minus 2. And that is my answer for synthetic division. All right? About synthetic division. Synthetic division works best when you do not have a coefficient in front of the x that you're dividing by. When it's just a binomial and it's x minus or x plus something, okay? Because if not, you're going to be doing this with a fraction, which is not usually the most fun thing. And then you have to divide that out of your numbers here. So you're going to want to use synthetic when it looks like this, x plus or minus a number. Question. It mentions here it is best to do it when you have just a small little binomial with no coefficient. So we're going to do this one. We're going to set it up. My coefficient of my x cubed is 1. I do not have an x squared, so I must put a 0 there. My coefficient of x is -7. My constant is 6. So remember, it's always the opposite here because it's what actually happens when you set it equal to 0. So I am going to, on the outside, I'm actually going to put a -3. -3 on the outside here. I'm going to add down 1 and 0 gives me 1. -3 times 1 gives me -3. 0 and -3 gives me -3. -3 and -3 gives me +9. -7 plus 9 gives me +2. -3 times 2 gives me -6. Remainder of 0. What does that tell me about this, by the way? It tells me it is a factor, okay? It tells me it is a factor, okay? My final step is to fill in my variables. I started with an x cubed. So what am I going to start with now? X squared. So I have 1x squared minus 3x plus 2. I don't have a remainder. This is my answer. Once I have these, I'm going to go back to my original and say, where did I start? I started with a cubed. I'm going to drop that exponent by 1 and just fill it in. So I'm going to start with this and say 3a squared and then just go down. Plus 3a plus 9. This is always my remainder, and I put it over what I divided by. Okay? So you're always going to be 1 less than what you started with, and then you're just plopping those back in. These are your coefficients. This is your remainder.